Assalamu alaikum. In this video, I'm gonna to briefly go over the essentials of hypothesis testing, and we solve some example from the book. The hypothesis testing, related to the hypothesis, we need to know what's the meaning of hypothesis. Is a claim or a statement about populations or parameter. Parameter like mean, variance, proportion, and so on. In statistics, we study a sample or samples and use the results to generalize on the entire population or populations. Suppose we have a claim on some samples, we need to generalize the conclusion by the hypothesis. Like this claim, the average age of all college students in a city is 24. Because always the H or the hypothesis null H naught always have equal, I will say that H naught such that mu equal 24 and the complement of equal 24 may be less than or greater than, and this will be alternative hypothesis, which is mu doesn't equal 24. So we have alternative and we have a null hypothesis. And remember, the null hypothesis must have equal and the alternative doesn't have equal. Also, sometimes it is a complement, not sometimes, always it is a complement. So we have this practice to see if we can know how to determine the null and the alternative hypothesis. A football player claims that he can achieve more than 100 rushing yards per game. So more than 100, this will be alternative, and the null will be less than or equal. And a cross-country star claims that it will take him no more than 4 minutes to run a mile. No more than 4 minutes will be the alternative, and the null will be less than or equal. We use hypothesis of two tail and one tail to test for testing. And the first one, when it is two tail, you will see that the null hypothesis has equal, like 23, then the alternative will be not equal 23. In this region, we can't reject the null hypothesis, and this blue region we call it a critical region. If we have an equal, then we have to divide the significance level over 2. If the test statistic we use it occur on the critical region, we will reject the H naught. In one tail we have the null greater than or equal 23, the complement will be less than 23. Because here we have less than 23, this will be a left tail. And here we have a greater than 23, this will be a right tail. The steps for the hypothesis testing: first step, state the hypothesis and identify the claim. We need to know the null and the alternative. Determine the critical values and region. Critical values came from significance level given from the question, and the region. Calculate the test statistic. The test statistic may be Z or T. If the sigma known and we have a sample greater than 30, we can use Z. If the sigma unknown and the sample size less than 30, we have to use T. Reject or fail the null hypothesis. If it is occur in the critical region, we will reject. If does not, we will accept, and we can say that we haven't proof to reject or accept. Nutrition representatives of company report that their product contains no more than 5 grams of fat. A researcher tests a random sample of 50 products and finds that X bar equal 5.03 grams if the standard deviation of the population is 0.14 gram. Use a 5% level of significance to determine whether there is a sufficient evidence to reject the company's claim. In this question, I did highlight some of these keywords: no more than 5 grams, and also the size 50, X bar 5.03, standard deviation 0.14, and significance level, which is 0.05, and we know to reject or do something. The first step: state the null and alternative hypothesis. So because we have no more than 5, will be alternative. Alternative will be mu greater than 5, and the null will be the complement. So the complement will be less than or equal 5. We need to determine the critical regions, the critical values of this. We have n greater than or equal 30, so we can use the z value, and we remember because it is greater, it will be right tail. Yes, we have 5% level of significance, and we can set alpha is equal 0.05. We can use our calculator by going to menu 7, inverse normal, enter 0.05, and you will get negative 1.6448. Yes, and because it's symmetric, we can take the positive because it's talking about the right. Then we have to calculate the test statistic for z. We have sigma is equal 0.14, n is equal 50, sigma x bar equal 0.14 over square root of 50, which is approximately 0.02, and use z by using calculator, enter the or substitute the value, you will get that z is equal 1.5. This the new value. Reject or fall. To reject the null hypothesis, H naught is not rejected. Why? Because 1.5 less than 1.645, and we can't or fail to reject. Practice number 2. Employees at bookstore claim that the mean wage per hour is less than the competitor's mean wage of 10.50. If a random sample of 20 employees shows a mean wage of 10.05 with a standard deviation of 0.75, test employees claim at alpha is equal 0.01. The claim, this is hypothesis testing. We have the mean, we have sample size 20, we have also the mu, which is 10.05 with the standard deviation of, which is s 0.75. Test the employee's claim at significant level 0.01. The alternative and the null will be greater than or equal 10.5, and the alternative will be mu less than 10.5. N equal 20 less than 30, use T distribution, mu 10.05 sample average sigma is 0.75, alpha is 0.01, which will be left because we have an alternative less than. Alpha is 0.01, degree of freedom 20, n, which is n minus 1, 19, and this will be 2.5339 by using the table. Approximately it is 2.54. Sigma x bar is equal sigma over square root of n. Use your calculator to find it, which is 0.167 t x minus mu over sigma x bar. Use calculator. 10.05 minus 10.5 over 0.168 give us negative 2.6785. This is the region which is left tail. This value came from alpha, this value came from statistic, and it is occur on the critical region. So because it is located in the region, H0 is rejected. Thank you so much.